Today I am going to differentiate Mendeleev periodic table, which is also called old periodic table, with the modern periodic table. First, we can say that elements were arranged in the order of increasing atomic weight in Mendeleev periodic table. But in case of modern periodic table, elements are arranged in the increasing order of their atomic number. How can we say so? I want to show you example. Look at this. This is old periodic table, Mendeleev periodic table. Here, hydrogen is shown here. Its atomic weight is written 1.008, and after this is blank, and after that we have lithium. Lithium its atomic number is 3, but here it is written 6.93 is atomic weight, and beryllium's atomic number is 4, but it is written 9.1. These numbers are atomic weight. In Mendeleev periodic table, elements were arranged in the increasing atomic weight from left to right. But in case of this modern periodic table, elements are arranged in the increasing order of their atomic number. Look at this hydrogen 1 and this gap, a big gap, and then helium as atomic number 2, and then lithium 3, beryllium 4, boron, carbon, nitrogen, oxygen 5, 6, 7, 8. In this way, each of the element has got a definite atomic number and they are arranged in the increasing order of their atomic number. This is one of the great difference between Mendeleev periodic table and modern periodic table. Now, second difference, there was not a fixed position for the lanthanides and actinides where in the Mendeleev periodic table, but modern periodic table it provides a fixed place for the lanthanides and actinides. Now, let's see the table again. Look at this modern periodic table. Here is lanthanum, atomic number 57. There are 14 elements after this lanthanum. They are taken here. That is from atomic number cerium to atomic number this 71 deuterium. In the same way, actinium. After actinium, 14 elements are missing here in the main body of the periodic table, but these 14, which starts from 90, atomic number 90, thorium to atomic number 103, lawrencium, 14 elements are separately kept at the bottom. Lanthanides and actinides has a proper place in this modern periodic table. But look at this old periodic table, Mendeleev periodic table. Lanthanides and actinides, they do not have any position in the periodic table. This was the disadvantage of Mendeleev periodic table. Now let's go to another point. Position of isotope was not clear, but isotopes are not taken in the table because elements are arranged in the order of increasing atomic number but not according to atomic weight. What it mean? I want to say something about this. Look at this. Hydrogen has got three different isotopes. One having atomic weight 1, another having atomic weight 2. This is protium, another deuterium, another tritium. If elements are arranged in the increasing order of their atomic weight, then after this hydrogen, first hydrogen protium, here we must have deuterium, and third must be tritium. Isotopes are not taken in the periodic table, but what is told, the elements are arranged in the increasing order of their atomic weight. That's why this is one of the disadvantage of periodic table. But in modern periodic table, they are arranged, elements are arranged in the increasing order of their atomic number. That's why there is no question of isotopes. Now next, in the place of one element, there were 2 or 3 elements in the Mendeleev periodic table. We can see this in the table also, but in each element has its own place in the periodic table in the series of a series that is from 1 to 109. Nowadays the same number 109 is increased to 118. New elements are discovered. Okay, let's see them. This is Mendeleev periodic table. And in place of one element in a box, here we have 3 elements: iron, cobalt, nickel. In the same way, another also here 3 elements. In other boxes also, look at this here. manganese, bromine, two are kept here in first group of periodic table. This potassium is kept with copper, and rubidium is kept with silver, and cesium is kept with this gold. There, in place of one element for a particular box, there were two or three also, three elements also in the Mendeleev periodic table. But in case of modern periodic table, each of the element has got a definite position in the periodic table. In one of the box, there is only one element. Okay, now let's talk about another point. Elements were divided into groups and periods only. In Mendeleev periodic table, there were groups and periods. But in modern periodic table, there are not only groups and periods, four distinct blocks. They are SPD and F block elements are separated. Look at this. Here we have Mendeleev periodic table. This is the period horizontal row of the element lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This horizontal row, this is one period: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Another period: hydrogen alone in a period. In this way, their elements are arranged in period. And elements are arranged in group. Look at that group number 1, 2, 3, 4, 5, 6, 7, 8. This group vertical elements which form vertical column of the periodic table is group. The elements are divided into groups and periods. But in case of modern periodic table, elements are not only divided into groups, vertical column only and horizontal row only. They are divided into four distinct blocks. Look at this is S block element group 1A and 2A, and in the same way P block element they are 3A, 4A, 5A, 6A, 7A, and 0 group elements are P block, and in the middle part of the periodic table it is D block, and at the bottom lanthanides and actinides are F block element. This way, not only into the group and period, in modern periodic table, elements are divided into four distinct blocks also. Okay, this much for today.